Second law of motion state. It is connected with acceleration, force, and mass. So, acceleration produced on a to mass of the body. So, from there we have got one formula F equals to ma. And third is what is Newton's third law of motion state? It is the easiest one. To every action, there is equal and opposite reaction. So, best example is there. You are sitting on the bench, right? So, you are sitting on the bench means you are applying some force on bench. That is action. What is that? Action. And the bench applies some forces to you so that you do not go down. Then that is reaction. Action, upward force is reaction. So sometimes question can be asked. There are two forces, action and reaction, but why don't they balance? Understood or not? Main reason is they don't get balanced because they act on different bodies. Action acts on bench when you are sitting, reaction acts on your body. Then they do not balance. They act on different bodies. So while using the boat also, what do? You use force backward, right? And boat moves forward. That is the thing. Okay, so here is also one question is example is here. When a bullet is fired from a rifle with a certain force, we apply some force. Yes or no? There is an equal and opposite force exerted on the rifle in the backward direction. That's why the rifle recoils. Bullet goes forward, rifle moves backward. Bullet's movement is action, recoil of rifle is reaction. Action and reactions are there. Okay, so in next period, we are going to discuss this, what to say, ex- activities of exercise. Now we have got here new topic. What is that? Machine. What is the topic? Machine. So I think the presentators are ready for their presentation, right? So who is going to present on this topic? Group B. Group B, who are the commanders? Please come. So now stage is for you. Okay? About pause for some time, then you can do.
Namaskar and very warm good morning to our science teacher and my dear friends. It's me Nistara Sai from grade 9 and here to present chapter 8 simple machine. Define simple machine and their use in our daily life.
Yeah, okay. I don't know. Do you have a light is better or without light? Or please come back, because you are yesterday those, then you should not go light, no? But from tomorrow you will be on time.
Or simple machine. The tools are simple devices which are used to make our work easier, faster, and more convenient. Are called simple machines. The uses of simple machine in our daily life are as follow. They help us to multiply force. They help to change the direction of force. They help to transfer force from one point to another point, and so on. Some term like effort, load distance, effort distance, work out, work input, work output, work input, mechanical advantage, uh, velocity ratio, and efficiency are used frequently as a simple machine. Mechanical advantages, advantage MA. It is a mechanical advantage represent as MA also. The ratio of the load to the effort in a simple machine is called mechanical advantage or actual mechanical advantage. Actual mechanical advantage represent at AMA of that machine. Mechanical advantage represent formula is to load upon distance and it is represented MA. Oh, load upon effort is equals L upon E. Simple machine. What is simple machine? Simple machine is the simple device which is used in our daily life which make our work easier. If there is no simple machine, it is very difficult to work our life efficiently. So here you can see the uses also, like it help us to multiply force, because when if there is no any force to our work, then we can complete or we can be success in that work. And it helps to change the direction of force, transfer force from one point to another point, and so on. And in our daily life we use frequently, like effort distance, load distance, work output, work input, mechanical advent, velocity ratio and efficiency, etc. uh, as you as you can see a figure also of a mechanical advantage. Like here is effort, I mean here is load and here is effort. If here is load, then here may be effort, but here is load, so that's why here in the end there will be effort. You can see here it is resistance. R means it is load distance, and effort distance, R means effort distance. And for support, there is a object which is called fulcrum also. And velocity ratio is present at BR. Velocity ratio of a machine, it is a ratio of velocity of effort applied in the machine to the velocity of load overcome by it. The ratio, the velocity of effort, the velocity of effort formula is distance traveled by effort upon time taken, represent at ed upon t. Also velocity of load, please remember this is very useful in our in the numerical problem. If velocity of if load is distance traveled by load upon time taken, represent at ld upon t. Also velocity of ratio br is equals velocity of effort upon velocity of load, represent at as d upon ed upon ld. Also efficiency, and it is represented as and the small n, the okay, small new. Okay, but it is written as like sir. How to make right?
No, you just click here. Yeah, it's here.
Oh, it is written as like this, but it was difficult to write. To write in that slide, so I write like that. It's better to write this because symbol is this. And efficiency. The efficiency of a simple machine is defined as the ratio of useful work done by the machine output work to the total work put into the machine input work. It means that the ratio of useful work done by the machine output the work is done by machine in the form of output to the total work input to the machine input. Then it means that output work is when to find a numerical problem of output, then you can just write the form. You can just remember the formula L into LD. It means load into load distance, and input work is effort into effort distance. Mm, mm. Efficiency as represented sir said that word, sir.
Eta.
Eta. And formula is output work upon input work into 100%. To find efficiency, you have to put 100% because efficiency is all about percentage. For if you forget to put 100%, then it may be wrong. So better to remember the formula. Relation between MAVR and output work upon input work into into 100%. Work done by if load work done by effort into 100%, represent as load into L into LD upon E into ED, multiply by 100%. And MA, you can, if there is given load distance, load effort distance and effort distance, then you can find by this formula. But if there is given MA and BR, then you can directly go to this formula. It will be more easier. The ratio, so that efficiency is the ratio of the relation, so that efficiency is the ratio of mechanical advance to the velocity ratio percentage. MA and efficiency of machine.
Okay, so let's do one more slide. Yeah.
Wear of a machine is not affected by friction. To be honest, I forgot to say that in VR and in MR there is no unit and it is affected by friction. But in VR it is not affected. But in VR also it is not affected by friction. But it also don't have unit, and because it is the ratio of two distance. But in MR it is a ratio of two force, so there is no unit. Due to this reason, VR value of MR is always found lesser than the
So
Yes,
one
sir.
thing you can click here. This one you can read from here.
Oh, yeah.
Right?
Lesser than of BR. We can reduce friction by the following method: by using lubricant like oil, etc., by making the sliding surface smooth, by rolling instead of sliding, by using ball bearing wheels and roller. For reducing the friction in VR, then you can use this method as I read. My portion was this much. Keep calm to be complete, to be continued. Thank you and have a good day.
Thank you very much, Ms. Tara. Actually, one thing you have to remember, teachers they give some technique, but students they apply in their own way and make more and more interesting and more creative one. So see, what is keep calm to be continued. Okay, I think this movie is not completed. I mean, this chapter is not completed, right? So this chapter will be discussed next day as well. So commanders will find out whose duty is tomorrow, and other group members, please remember, whenever they complete, then your turn will come. Accordingly, prepare your slide much more better. Children, let me talk something here. In this class, just before we have discussed some formulae. Some formulae are there. Number one, MA. What is the formula? MA, mechanical advantage. What is the formula of mechanical advantage? Right, load by effort. Actually, these both are forces, right? If this is the ratio of two forces, then it is cancelled. That's why MA has no unit. He said MA has no unit because it is the ratio of two forces. Next one, there is VR. What is the formula of VR? ED upon LD. ED upon LD. Or in definition it was given the ratio of velocity of effort by velocity of load. Velocity of effort is ED by time. Velocity of load is LD by T. Then when we find the result, that means ratio ED by T divided by LD by T, TT cancel this lower one. And what do you get here? ED by LD. So this is the formula of VR. VR formula is ED. ED means distance traveled by load. Sorry, effort. ED is distance traveled by effort. What is LD? Distance traveled by load. So I will just make you clear about this ED and LD. So her it is here. So see here, children, what is given? Here is one fixed point. What do you call this fixed point? Fulcrum. It does not move at all. But one thing you have to keep in mind, fulcrum may lie at any region, either at the center or at any end, either first end or last end, right? That is fulcrum. That's why we have discussed about three type of levers: first class lever, second class lever, and third class lever. And to find the a type of lever, one formula we have learned, that is FLE. What is the formula? F means in first class, fulcrum lies at the center. In second class, load lies at the center. In third class, effort lies at the center. So what type of lever is this? So see, the fulcrum lies at the center. That's why it is called first class lever. So load is connected at one side and effort is applied at another side. Distance between load and fulcrum, what is it called? Load distance. What is it called? Very simple. Distance between load and fulcrum is load distance. And distance between fulcrum and effort, what is it? Effort distance. Okay? But if the simple machine is done like this, where is the fulcrum located? At one end, right? Then what is here? Load. What is here? Now can you tell me what type of lever is this? FLE, right? So second class lever. Then what is this distance called? And what is this distance called? Do you know? Load to fulcrum, that is load distance. Effort to fulcrum, what is this? Effort distance. In this case, load distance is much more shorter than effort distance. But here may be equal. Yes or no? Two formulae you have discussed. Next formula, what we have done? MABR. Another formula is efficiency. Efficiency, how do we denote? Eta. What is that? Eta, Greek letter eta, equals to work output by work input, or output work by input work. Output work, how to find out? Load times load distance. And input work? Effort times effort distance. Sometimes they may ask us to derive one formula. Ashwin, look at here. Eh? Then, now you have to be very smart here, children. Load by effort we can write here. Done. Then below, what is here? Effort distance by load distance. This step is very, very important. Load by effort, I have taken it once. Already there is effort distance, I brought load distance at last. These terms can be written in this way also. Load by effort distance, by load distance. Now, tell me, what is the formula of L by E? What is that? MA. And ED by LD? VR. So here must be how much percent? 100%. Efficiency is always expressed in percentage. Yes or no? So, percentage, 100%. So, what is the formula of efficiency? MA by VR multiply by 100%. Okay, MA by VR multiply by 100%. So what is output work? L times LD, or the work done by the machine. The work done by the machine. And input work? The work done in the machine. Input means inside the machine, in the machine. Output means which comes out, right? Okay, what do you think? Output work and input work, are they equal or unequal? What is your opinion? Output work is always less than input work. Output work is always less than. Why? Because of one villain. What is the name of that villain? Friction. So, what is friction? When any two objects are brought together, right? Then one force is produced in between them, which opposes the motion. Which opposes the motion. You know, you want to play the football or volleyball, this and that. When we hit the football, it travels some distance, right? After some time, does it come to the rest or not? Why does it come to rest? Because of two forces. Because of what are the two forces? One is force of gravity, or attracts it, right? Another force is friction. You know, when you complete your meditation, then I say, okay, produce cosmic energy. Do you rub your hands or not? When you rub hands, then these two objects, they come in contact or not? These two hands, they come in contact or not? Then there is development of force and heat is produced. I come in my bike. At the beginning, the engine is cold. Is it cold or not? When I reach here, can I touch the engine? Why? It's very hot, right? Why does it become hot? Because of friction. Because of what does friction do? Opposes the motion. Its main duty is to oppose the motion. So, to minimize the friction, I use something in the engine. What is that? Right. Mobile is used. Petrol is used for producing energy. Understood or not? Don't buy that bulb. And mobile is used, or grease is used, or oil is used to reduce or minimize the friction. Sometimes our doors produce uneasy sound. Have you noticed or not? Choing, 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 sound is produced, right? And how do you minimize that? You have got mustard oil at home, or sunflower oil is there, or soybean oil is there. Some drops you keep in that place where sound is produced, it will be minimized. Because use of oil, use of grease, use of mobile decreases the friction. Understood or not? There are different ways of decreasing friction. What are they? By using lubricants. Not only by using lubricants. Next one, by using ball bearings. They use balls, small balls, iron balls. And you know, what is the shape of the wheels of vehicles? They are circular, or round, or flat? Round. So, if they are made flat, then what about those vehicles? Can they move fast like that? They cannot, because friction will be higher one, isn't it? So, ball bearings, rolling, sliding, using lubricants, we can minimize the friction. Next important thing, mechanical advantage is affected by friction, but velocity ratio is not affected by friction. So, in a simple machine, mechanical advantage is always less than velocity ratio. So, what do you think? Can we get the machine with 100% efficiency? Why? Because there are some moving parts. Moving parts means what is produced? Friction is produced. What does friction do? Increases force or decreases the force? Increases the work or decreases the work? So, output work is affected by friction, but input work is not affected. For example, if I write the efficiency of a machine is 80%. Okay, what is the question? Or statement? Statement of a machine is 80%. What does it mean? And what should be your answer? 80% work is useful work and 20% work is reduced by friction. Remember, input work was 100%, but only 80% is useful. Next 20% is wasted by friction. If the efficiency is 30%, then what can you say? 30% is useful work, 70% is wasted by friction. So should you use such type of faulty machine? It's better to throw in dumping site. What's the use of that one? And if the machine has 100% efficiency, that machine is called, what do you call it? That is imaginary machine only. None of the machine has efficiency more than, equal to 100%. But if we imagine the efficiency of a machine is 100%, then what is it called? Ideal machine. The machine whose efficiency is 100% is called ideal machine, or what is that? Perfect machine. My mode of this mobile, that is also a kind of machine. When I use for a little bit longer time, does it get heated or not? Why does it get heated? Because there is also what is produced? Friction is produced. Understood or not? Okay. So children, what to do? You open your book once again and please read up to this portion, that from the beginning to the way of minimizing friction. That is first part. Second part is note making. Is that clear? Please start now.